Let's keep talking about solving. Now we'll solve by factoring. This is going to be probably a long video because it's going to have a ton of examples. So I recommend once I get to kind of the example portion of the video, maybe you can see how much you need or what you need to practice with and look ahead at some problems that you might want to do, but you might not need to watch all of this. Also, this isn't going to be an introduction to factoring. It's something that we've learned before in this class. So if you're here to get like an intro to factoring, I'll link some videos that can help you, but this is kind of a review and then talk about solving. When you factor, the first thing you want to do is pull out the greatest common factor, meaning a term or expression has something in common all throughout it. Find what that is and pull it out. So in this case, all three of these terms can be divided by 2 and can be divided by 1x. And since the first term is negative, I'm going to pull out a negative 2x from everything. Negative 2x is my greatest common factor. So I pull out a negative 2x, and that leaves me with 4x to the 4th minus 3x plus 1. I'm dividing everything by negative 2x. So this got divided by negative 2x, as did this, and that left me with these three things. So this is me factoring out the greatest common factor. You should always try to do that first. Whenever you are factoring, pull out a greatest common factor. And when you're factoring, what you're doing is you're taking an expression and writing it completely in terms of multiplication. There's still addition or subtraction inside these parentheses, but this is now a factor, and this is now a factor. And when these two factors multiply, you get the original expression. So over here, everything can be divided by a y, and everything can be divided by a 2 again, because I don't think, 4 and 6 won't work, so it's 2 again. So all I can pull out of this is a 2y, leaving me with 9x minus 6xy plus 4y squared. This is now factored. Technically, we would probably want to have this listed first. It's often best to live things with the powers in decreasing order. So if I was going to do this in standard form, I would do 4y squared minus 6xy plus 9x. Standard form is powers in decreasing order. So here's two y's, here's an x and a y, so still a power of 2, but one of each variable. That's got a power of 1 on it. Always plot a greatest common factor first. Look for a difference of squares. A difference of squares is when you have two terms that are both perfect squares, and there's a subtraction in between them. It can't be addition, it has to be subtraction. If you have a difference of squares, it's factored into square roots. So the square root of x squared is x, and the square root of 16 is 4. And we do that twice. One of them is positive, one of them is negative, it doesn't matter which. X plus 4 times x minus 4 gets you x squared minus 16. So these are both perfect squares. This would be 4x minus 7 times 4x plus 7, and this is now factored. A difference of squares is very, very simple to factor, but also somewhat common and quite useful, so look for that whenever you can. But where we'll spend most of our time is factoring a quadratic trinomial. Quadratic means biggest power is 2. Trinomial means there's 3 terms. There's several ways to factor a quadratic trinomial. I'm going to show 2 of them, and then I'll link some videos that show other ways. You need to find whatever works best for you and just go for it. First of all, if the a value is 1, if there's a 1 in front of this x squared, the factoring is much simpler than if the a value isn't 1. So right now we have x squared plus 7x plus 6. I'm trying to find 2 numbers that multiply to 6 and add to 7, and those numbers are 6 and 1. So it's x plus 6 times x plus 1. You want numbers that multiply to c and add to b. Remember, we have ax squared plus bx plus c. Multiply to c and add to b. Technically, you want numbers that multiply to ac and add to b. But because a is 1 in this case, multiplying to ac is just the same as multiplying to c. So when the a term is 1, you want numbers that multiply to c and add to b. So numbers that multiply to negative 14 are those. Those are all 4 numbers multiplied to negative 14. The pair that adds to negative 5 is those. So it's going to be x minus 7 times x plus 2. And I've not done any checking yet. But to check these, whenever you factor and check, you just do the distributions. So x times x is x squared, x times 2 is 2x, negative 7 times x is negative 7x, and negative 7 times 2 is negative 14. Combine these, x squared minus 5x minus 14, so it checks. This is my answer, and I don't like using the term answer. That's the factored form. This is the standard form, expanded. Since they're the same, that means we factored correctly. Now, a key thing about factoring, solving by factoring. So far we've just done factoring. We haven't actually solved yet, but I want to talk about what happens when you solve. There's something very special about the number 0. The special thing about the number 0 is if you have two numbers that multiply to 0, you know one of those numbers must be 0. Possibly both. But at least one of them has to be 0. That's called the zero product property, the ZPP, which, you know, we can all be down with. A and or 0, A and or B must be 0. That's not true with other numbers. Like if A times B is 2, then A could be 2 and B could be 1, but A could be 4 and B could be a half, or A could be 6 and B could be a third, or A could be -1 and B could be -2. We don't know anything about A and B except for A times B is 2. But if A times B is 0, one of them has to be 0. Which means I can come over here to something that's factored. Think of this like it's A, and think of this like it's B. And if x minus 3 times x plus 2 equals 0, we know that either this is 0 or this is 0. And in fact, we want both cases to be true. We're going to find the two things of x that solve this. So I set the equation equal to 0, or the factor. One of my solutions happens when x is 3. One of my solutions happens when x is -2. Factoring works and only works if you're equal to 0. Write things in terms of factors, set the factors equal to 0, and solve. So, I'm going to solve these equations by factoring. Now, right now, the a value is no longer 1. The a value is now 2. So there's two ways to go about this. One is by guess and check, and one is by grouping, and basically every other form of factoring is one of those two derivatives. It's some way to guess and check or to group. When you guess and check, you just draw out two parentheses, and in the beginning of each parenthesis, figure out what x could be. So I know it has to be a 2x and an x in the front. Now that I know what goes here, I've got to figure out what goes here, in these slots. There's not a lot of options in this case because 3 is a prime number and 3 is a small number. In fact, it's prime that really matters. It could be, I want numbers that multiply to 3. And the order in which I put them matters because whatever number goes here gets multiplied by this 2. Whatever number goes here is multiplied by this 1. And I've got to start just playing with options. So I can just set up really all 4 possibilities. And I can have -1, -3, +1, +3, -3, -1, or +3, +1. Hopefully one of these 4 possibilities gets me a middle term of -7. That's my goal, to get to a middle term of -7. And I actually got it in the first one. Here is -1x. Here is -6x, because 2x times -3 is -6x. -6x minus 1x is -7x. So I've actually factored 2x squared minus 7x plus 3 into 2x minus 1, x minus 3. Those two expressions, those two equations, are the same. Now, to solve this, I know that this bubble here has to equal 0, and this bubble here has to equal 0, and I solve both of those. Add 1, divide by 2, add 3. These are my two solutions. That's solving by factoring. I think the guess and check method is really good if you can do mental math quickly, or if you do a lot of practice with it, or if you have done a lot of practice with it. It's usually the fastest way to factor. I almost always start by guessing and checking, then if that doesn't work, I try something else. Okay, factoring only works if equal to 0. So if you don't have an equation that's equal to 0, make it equal 0. You have that kind of power. Add a 6 to both sides. So 2x squared plus 7x plus 6 equals 0. I'm going to make some bubbles here. 2x goes here, x goes here, equal to 0. To get to 6, I can do 6 and 1, 3 and 2, or -6, -1, -3, -2. And all of those things can switch spots, because again, whatever goes here gets multiplied by 2. So one thing I could do is go through and multiply all these numbers by 2 and add 1 to them. So like 2 times 6 is 12 plus 1 is 13. 2 times 3 is 6 plus 2 is 8. 2 times 6 is 12. Minus 1 is -12, -13. These aren't working out. Is this one possible? Yeah, I put a 2 here and a 3 here. Yeah, 2 times 2 is 4 plus 3 is 7. And I make these positive. 2x plus 3x plus 2. Now here's a 4x and here's a 3x. 4x plus 3x is 7x. So I need to solve now. X equals negative 3 over 2. X equals negative 2. This was a 0. Take my word for it. That's guess and check. Another way is called grouping. Grouping is longer, but the nice thing about grouping is it gives you steps to follow that will always work. If you follow these steps correctly, you'll always get to something that either can be factored, and you know the factors, or you just know it can't be factored. So whenever you write out all the steps to doing something, it looks terribly long. But these three things actually just go really quickly. And these two things here go pretty quickly. It's these middle two steps that tend to cause people the issue. First, whenever you're factoring, pull out a GCF. In this case, I can pull out a 2. And that 2 just hangs out, just sits there outside this whole entire time. It's just going to sit there. Don't worry about that, but don't lose it. Next, after you've pulled out the GCF, which I call step 0, step 1 is to multiply A and C. A times C is negative 15. Step 3, or just step 2 really, find the pair of factors of AC that add to B. I'm going to write out all the factors of negative 15. I want to find the pair that adds to B, and the B term is now positive 2. The signs are so important, don't lose track of your negatives. The B term right now is positive 2. This pair adds up to positive 2. Now this is usually the part where students get confused with the factoring by grouping method. This B term, 2x, is going to get split up into these two terms here. So 2x really becomes negative 3x plus 5x. All the stuff around it, like the negative 5 doesn't change, the 3x squared in front doesn't change, the fact that this is all being multiplied by 2 doesn't change. Just the 2x became negative 3x plus 5x. Notice that this equation here is expression equals this one and equals this one. All three of these expressions have the same value. If I were to expand, to simplify this or simplify this, I would get back to this. So I've not changed the value of anything. I've just rewritten the way it looks, which is why I can chain it with these equal signs. Now, the magic happens. Slash this in the middle. Make two different groups. And again, this 2 is just going to sit up there in front. I'm now going to use a big bracket instead of a parenthesis and change color slightly. I'm going to factor out a GCF from here. Both these have a 3x in common, so I pull out a 3x. That leaves me with x minus 1. I'm also going to factor a GCF out of here. I can pull out a 5. Since it's a positive 5, put a plus there. Had it been a minus 5, I'd put a negative there. I pull out a 5, that leaves me with x minus 1. Since those two bubbles worked out the same, x minus 1 and x minus 1, this can keep factoring. We actually knew this was factorable once we got to this step. Once we found two numbers that could multiply to AC and add to B, once you get through step 2, that's when you know your problem is factorable. If step B, if you shut down there, if you can't find two numbers that work, it can't be factored. But now since these two bubbles are the same, the stuff in front of them combines to another bubble. So I'm going to have 3x plus 5 times x minus 1 with the 2 out in front. I have now factored. That is factoring by grouping. In some cases, I think that's easier than guessing and checking, but like I said, I usually guess and check first. I'll do one more example of this, and if you want more examples, I'll post a link to another of my videos showing it. If you can't guess and check, I think grouping is a good method. Like I said, the problem is it's long, it kind of feels cumbersome, but once you start doing it a lot, it can go very quickly. This equation wasn't an equation. We couldn't solve it because there was no equal sign. All we could do to this was factor, because it wasn't equal to anything. And just factoring for the sake of factoring has actually a lot of merit and utility and value in a lot of places. Although for now, we're mostly just factoring for the sake of solving. So I am now going to solve this one by grouping. It's got an equation, an equal sign, so I can do more with it. What color do we want? Let's go with this pink. First, plot a GCF, which again is 2. And I'm going to do a bracket there. Next, multiply a and c. A times c is 12. Next, write out all the factors of 12. There's a lot of them. However, I know I just want to get to 7, so I'm going to want the 3 and the 4. But here's all the factors of 12. I recommend when you make a list, you make it in a very organized fashion. By which I mean I'm going like counting down and counting up on one side so I don't miss anything. Find the pair of numbers that add to 7. That's this pair right here. Now I'm going to switch colors for dramatic effect. This 7x will split into 4x plus 3x from those two terms there. But everything else around it stays the same. So we have 2 times 3x squared plus 4x plus 3x plus 4 equals 0. Now I split into bubbles. So I slash this in the middle. On the left half I can pull out just an x, leaving me with 3x plus 4. On the right half I can pull out nothing. They have nothing in common, so I'm going to put a plus 1. Just because I want to be able to pull out something. And that still leaves behind a 3x plus 4. Don't forget the 2 is here. Let's make this pink. And again, because these bubbles were the same, I can finish this factoring. So now I have 2. These go into one bubble. These go into one bubble. And I have factored. I have not solved, I've only factored, but that's good, now I can solve. Take my two bubbles, set them both equal to 0, and I get x equals -1 and x equals -4/3. A nice little hint. When you're solving, it's always going to be the opposite of this divided by this. So if you have 3x plus 4, it's -4/3. I could plug these back in for x to check them. They're going to come out to 0. I've checked my word for it. It's factored, it's solved, it's beautiful. There's a method that they take these processes and they structure them in different ways. So one thing is called the x to the diamond, where you put AC up here and you put B down here. So like here, first I'm going to pull out a 2. This is the same problem as before, just done a different way. Up here we put AC, which is 12. Down here we put B, which is 7. And then in these two spots, we try and just put numbers that will multiply to 12 and add to 7. Ah, there it is. It's just a kind of a way to show what's happening with, or give you a structure to put things in your brain. So there's nothing new happening here. I still have to, from this point, go into 2 times 3x squared plus 4x plus 3x plus 4 and split it and factor it. None of that stuff changes, but it's just a way to scaffold what's happening in your mind. Some people find it really useful. There's a box that kind of does the same thing. There's a Korean method that's basically guess and check, but it's structured very nicely. There's lots and lots and lots of ways to factor. And like I said, I'll post a link for you. But find the one that works for you and stick with it, and try some others while you're at it. I'm going to do some examples here. And if you feel like you're good with factoring, this is a decent time to skip ahead a little bit. But if you want to watch or pause and do these, that'd be good. Here the a value is 1, so the guessing and checking is pretty easy. Blech. X, I want numbers that multiply to 12 and add to -8. So it's that -6 and -2. So x equals 6 and x equals 2. I have to subtract the 3 first on this one. Two times 6 is 12. So if I'm going to try and guess and check this first. I'm going to put a 2x here and an x here. And I can do 6 and 1 or 3 and 2. Those are my only options to multiply to 6. This one can't factor. Yep, not factorable. If something isn't factorable, that doesn't mean it's not solvable. This one I don't think is solvable, but just because something can't be factored doesn't mean it can't be solved. It just means that the solutions aren't really pretty, by pretty I mean like a whole number or a clean fraction. I'll also guess and check this one, 2x, x. I can just do -3, -1. I'm doing negatives because this is negative. If I put the 3 here and the 1 here, and I make these both negative, there's -2x minus 3x for -5x. So my solutions are going to be 3/2 and 1. So what I did is I took 2x minus 3 and set it equal to 0, and took negative x minus 1 and set it equal to 0 and solved those, but that's going to get you there. Opposite of this divided by this. Last one, and here's just the steps that I follow for factoring. Pull out a greatest common factor, look for special cases. We'll actually have a new video talking about special cases next. It'll just cover a few different ways of factoring to make it faster. Factor by grouping and guess and check or some other method, but then check when you're done. It's possible after you've finished factoring, you're not actually done factoring. You can go further. So I'm going to subtract 4 from both sides here and get 6x squared plus 20x plus 6 equals 0. I can pull a 2 out of all of these things. I'm going to guess and check because this is prime and this is prime. If those numbers are prime or if they're small, guessing and checking can be nice because there's not a lot of options. If I do a 3 and a 1, 9 plus 1 is 10. So my solutions are going to be negative 1/3 and negative 3. Done. Hey, thanks for watching. I hope that was helpful. If you have any questions, leave them in the comments down below. There can be questions about the video you saw here or anything else in math I'm happy to help with. Subscribe if you'd like to watch more videos or see other updates as they come. I'm going to try to run through all of Algebra 2 Trig and then eventually hit more classes like Algebra 1 and Geometry and Pre-Calc and everything else. If you have questions about stuff covered that's not in this video, still let me know. I'm happy to help. And finally, if you're not one of my students taking the class, but you found the video and are watching it, or maybe you're a teacher and are watching it, you can buy the curriculum and buy the worksheets to go through it. That's found at the website listed down below also. So again, thanks for watching. Have a wonderful day.